Logic coverage is an important aspect of software engineering. In this video, what we want to do is we want to talk about how logic coverage influences our testing of systems. So our goal from this video is we want to be able to define the terms predicate and clause, the concept of short-circuit evaluation, the concept of predicate coverage and clause coverage as they relate to testing, the concept of combinatorial coverage, and we want to lead to eventually this concept of active clause coverage, which we will use to create some tests. We're actually not going to get into in depth about inactive clause coverage or in specific the concept of infeasibility in this lecture. So what is a predicate? You've been dealing with predicates really since your first year of programming. A predicate is essentially an expression which evaluates to a Boolean variable. So if I have a Boolean variable, for example, done, or if I have a Boolean variable, keep going, that's a predicate. The negation operator, the not operator, and an or operators, that's a predicate. The implication, exclusive or equivalence operator. All of these things essentially are expressions which evaluate to a Boolean variable. We can think about these expressions as being something that we have a truth table for. Predicates can be simple or they can be more extensive. So for example, I could have a predicate x is greater than 5 or z is less than 2 or name dot length equals 7, for example. All of these are essentially predicates. Or essentially, this is a predicate here, in that it returns a Boolean value when it's done. It is either true or false. So predicates are very, very important aspects of programming. Now predicates are made up of parts called clauses. Not Santa Claus, but clauses. A clause is a predicate that does not contain logical operators. So for example, if I had a statement such as the following: A equals B, or C ended with P of X. This right here is a clause in that we don't have a logical operation. All we have in here is a comparison. C here is a Boolean variable. Again, we don't have any logical operators associated with it. And P of X here, this is a method call which returns a Boolean. So clauses essentially, again, are a predicate without any logical operators. This whole thing is essentially one predicate, but what we have on this essentially here are three clauses. Now when we start talking about predicates and these types of systems, we end up with some challenges related to order of operations. And these order of operations are not consistent across all languages. That poses some interesting challenges. So for example, if I have normal code where push basically puts an int on to the stack and pop pops it back off, if I have this code right here, what's going to be the result? So for example, I'm going to build a stack here. And I'm going to have in this stack 5, 6, 8, and 2. And what I'm going to do is I'm going to call this line of code. Now, the first scenario that I have, obviously, we know that the part of the stack that's going to change is this part up here. So in my first scenario, what's going to happen is I'm going to still have this 6 and 5 staying unchanged down here. What's going to happen is this first pop is going to get the 2, and the second one is going to get me the 8, which is going to result in me putting onto the stack, right here, -6. But it is very possible in another language that we could actually execute this code in a slightly different order. So I'm going to put my 6 and 5 down here. I'm going to say that in reality what happens is this first pop is the second one, and then the first one gets called, which results in 8 and 2, putting a +6 on top. This is an order of operations challenge. Now, a language such as Java always works left to right. But a language such as C or C++ may do this type of code differently depending on a concept called sequence points. And sequence points are things that the compiler may optimize based on what it's trying to do, resulting in these two different types of values. Where we see order of operations potentially impacting things is something called short-circuit evaluation. Now, short-circuit evaluation, also known as McCarthy evaluation, essentially means that I will only evaluate an expression or a predicate until I know the outcome. So here I have an example. If denom, n num divided by denom, this first right here, and again, this piece that I'm showing you is a segment of C or C++ code. This would not work for Java. If denom, and num divided by denom, what we do with this first part is we ensure that this is not going to result in not a number. Because if we think about it, if denom is ever 0, this is going to go to infinity. So with short-circuit evaluation, what will happen is this first part of the code will evaluate, and if this is true, then we evaluate the second part. If it is false, we skip the second part. Now, short-circuit evaluation is very, very useful for us. In this scenario here, I have an AND, which means I only evaluate part of the statement. This second part here, obviously, can be true or false depending on the relationship or the value of the numerator, whether it be 0 or not. But if the denominator is 0, we're going to completely skip through that second part because of this check right here at the beginning of our code. So here I have a piece of code that deals with basically here a Boolean expression or a Boolean variable. And here is a method call. Now, if that method has a side effect, where a side effect means something changes, then we run into a problem with short-circuit evaluation, potentially, if we're not careful in our design. So in this first scenario, what we would have here is if is high is true, then what we're going to do is evaluate f of x equal to x. And that can either be true or false. And we'll either, based on that, go into this piece of code that I'm going to call here A. If it's false, we won't. But in this, if this is high is false, we're not even going to bother, or we're not going to essentially call, because there's no reason to do so. We've already determined that this is going to become false. So short-circuit evaluation, if we put it into a concept, essentially says that we will stop evaluating a logical predicate when we know the outcome of that predicate. Now, our simplest form of coverage when it comes to the form of logic coverage is the concept of predicate coverage. Basically, predicate coverage is very, very simple in that it requires that our predicate evaluate to true and our predicate evaluate to false. So let's take a look at this predicate that I have right here. I can actually obtain predicate coverage on this very, very easily with essentially two test cases. So in my first test case here, and I'm going to draw these out here as a chart, A, B, C, and P of x, like so. And I'm also going to put my predicate value out here on the edge just so we can prove that this works with 2. I'm going to pick A having a value of 5 and B having a value of 4. So what that's going to make is this first clause is going to be true. I'm going to pick C to be true, which means this clause is true. And I'm going to pick P of x to be true as well, which that results in my predicate being true. For my other test case here, what I'm going to do is I'm going to pick 5 and 6, which is going to make my predicate here be false. I'm going to pick this to be false, which makes that false. And I'm going to make P of x be false, resulting in my predicate being false, like so. So I have two test cases that have completely covered this predicate. To translate this into code, what we would essentially have is the equivalent of an if on the front of this, like so, and these operators obviously would change to be the appropriate OR operators and the appropriate AND operators, and then we've got a piece of code that we can test. Now, if you think about it, I am making this be both true and false, covering or obtaining predicate coverage. But is that very good coverage? All in all, I would say no, it's not. So let's go on to another form of coverage. One of the other things we want to look at is the concept of what we call clause coverage. Clause coverage basically says that for each clause in the set of all of the clauses, our test requirement is that we evaluate C to both be true and to false. So let's take a look at our predicate here. So we have the exact same predicate that we had on the previous slide. A is greater than B or C, and with P of X. So what I need to do in my testing is I would need to make sure that I have A greater than B being both true and false for that predicate. I want to make sure that C is both true and false, and that P of X is both true and false. That leads me to a set of test conditions that I can come up with for testing the entire system. So with predicate coverage here, I could come up with a set of test cases here. And what I'm going to do is I'm going to have A and B be passed in here, like so. And I'm going to have C as well. And I'm going to have P of X. And then, of course, what I want to do is I want to look at the whole predicate, for example. So I'm going to start here by coming up with my scenario where I want A and B to be true, or A greater than B to be true, for example. So I'm going to pass in, for example, 6 and 2. And I'm going to pass in for C here a value of true as well. So I've got these predicates being the case. And then what I'm going to do is I'm going to have P of X being false. So my overall predicate based on this is going to be false. I'm going to then have another clause coverage set where I'm going to set A greater than B to be false. So 2 and 6. That results in false. I want C to be false. And, of course, P sub X is going to be true. But if you think about it with this AND operator that we have right here, the whole predicate is still false. So again, if this was an if statement like so, the code that's right in here would not be executed based on these test cases, even though we have obtained clause coverage in this example, or on the previous example, predicate coverage. So all right, that gives us a challenge. What we find is that predicate coverage does not necessarily fully exercise all the clauses, especially if we have short-circuit evaluation. Clause coverage, as we just saw, does not necessarily ensure that we have predicate coverage, which is not good. So we can satisfy clause coverage without the predicate being both true and false, as is given by the example. All in all, when we think about it, that is bad. We do not want our system to behave like that. So to get around that, we need to come up with some other approaches. So one of the things we can come up with is combinatorial coverage. So combinatorial coverage, what I'm going to do is I'm going to split these clauses, and I'm going to rename them a little bit just to make life a little bit easier. I'm going to call this X, Y, and Z. And if I take a look at this, we can then draw a truth table for this, X, Y, Z. And I'm going to have false, 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 true, false, true, false, false, true, 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 false, false, true, false, true, true. Whoops, I think I made a mistake there. Let me get this back to where I'm at. So, there we go. So this should be true. That's going to be true. True, false, true, and then true, true, false, and then finally true, true, true. This is our overall system, and then what we find is that my predicate that I define here, if I have all falses, this is going to be false. If Z is the only thing that is true, this is still going to be false. In this scenario here, if C is the only thing that's true, this is still going to be false. If I have C and Z or Y and Z being true, that's going to be true. This is going to be false. That's true. This one's going to be false. That's true. So what we see is, from doing this, first off, that I have 2 to the n possibilities. That's a lot of possibilities to have in my code. So 2 to the n possibilities poses some interesting challenges. Combinatorial coverage is very expensive if we have multiple clauses in our predicates. You can think about this as really being the same types of things that we went through in digital logic as we also and worked through the logic and the Boolean algebra approaches. Now we do start to see certain elements that may be a little bit more important. For example, if you look at something, if Z is false, it's always false. That gives us something to think about, something to ponder as we go forward here. Is potentially Z a more important clause to this overall predicate? That leads to the concept of active clause. I could see that P sub x was more important in the overall assessment of the system's behavior. The other clauses, while they certainly did impact the behavior, P of x really makes a difference. If it's false, the predicate is false. That's going to have some impact on my testing if I really care about what's happening over here. And that may be something that I'd want to focus on, making my system work a little bit better by testing that particular sets of situations. This leads us to a couple of definitions. So the first concept is this concept of what we call a major clause. The clause which is being focused upon. Minor clause is all other clauses in the predicate, essentially everything else. And lastly, the concept of determines. A clause C sub I in predicate P is called the major clause, determines P if and only if the values of the remaining minor clauses C sub J are such that changing C sub I changes the value of P. So basically what we're looking at is the concept of C sub I being the one that actually is controlling the behavior. The other clauses don't matter quite as much. So really, to test the outcome of a clause, the clause should be determining the factor in the value of the predicate. So with this, we see, or if we select P sub x as a major clause, we see that there's one set of outcomes with its false, where it really doesn't matter what the other outcomes are. And then we see that if it's true, it does matter what's going on in these other clauses. That really helps us when we're starting to hone in on how we want to approach testing. Here is the code that implements our print honor roll status method. Now we can see this is kind of made up. You probably wouldn't actually implement it this way, but it does give you the idea of what we're looking at. So what I want to do is I want to focus first on this first predicate right here, and some of the various conditions that we would have to have in order for things to happen. So if I look at this, there are 4 inputs that are required for this to essentially be something that we would care about. And what I want to do is I want to take a look at them, again, using this concept of major and minor clauses. So I've got credits completed, the cumulative GPA as a parameter, the full-time status, and the term GPA. And then obviously I've got my overall predicate. So what I'd like to do is I want to first focus on credits completed here, being, in our example, the major clause. So based on that, what I want to do is I want to get true and false. And actually what I want to do is I want to set the false one first. So from this, if I want this to be false based upon credits completed, I've got to have this clause become false, which means my credits completed has got to be less than 30 hours. So I'm going to say 29 hours. My cumulative GPA, 3.3. My full-time status has to be true. And my term GPA has got to be something like a 2.4. I'm just picking these numbers up. Now, if I want that clause to make things be true, I'm going to set this to 31, and I'm going to set my cumulative GPA terms and these other guys to be the same things. Note, these are the same. That has made that first clause be the active clause. Now, if I'd like to make the second clause be the active clause, again, where I've got false and true, where that one governs things, my credits completed in this scenario has got to end up being greater than 30, so I'm going to pick on 31. My cumulative GPA is going to be such that it's false, so that's okay, so I need it to be like 3.0. My full-time status is true, and my term GPA is again going to be something like a 2.4. Now to make it be true, 3.1 or 31, 3.3, true, 2.4. Notice I kept these other things the same. Now, based on making the full-time status be my active clause, if I want it to be false, I've got to have false. I've got to have true if I want it to be true. Everything else should be true in this case, so 3.1, 3.3, 2.4, 3.1, 3.3, 2.4, like so. And then finally, last but not least, if I want to make this last clause be the active clause, again, having that drive things to be false and true, what I've got here is my term GPA being greater than 2.0 and less than 2.0, so 1.9. And everything else being true, so I'm going to say 31, 3.3, true, 31, 3.3, true. Now, if you think about it, I have 4 clauses. If I was doing combinatorial testing, I would have 2 to the 4 combinations. which in this particular case would be 16. But I'm able to do this with only 8 by using this major and minor clause concept. The other thing to note is, for example, this clause right here, or this test case right here, is an exact duplicate of that test case there. So by using this, it's even possible that I could cut this down to be less than 8. Maybe even having less than what I've got by possibly writing my clauses a little bit better. In fact, actually, as I look at it here, 3.1, 3.3, true, 2.4. This is identical. That is identical. So you notice that those 4 match exactly the same. So what I'm able to do is, by using this active clause scenario here, I can actually test this with 1, 2, 3, 4, 5 test cases. 5 test cases versus 16. That's the concept of active clause coverage. So here I'd like to take a look at another real-world example. That is the probability of school closing. Now, this is dependent upon the temperature, the wind speed, the inches of snow on the ground, and is another large school nearby closed. So what we find out is that there is a high probability or a low probability. So we have 2 different sets of conditions that give us high probability. Otherwise, we're essentially at low probability. So what I would like to do based on this is take a look. Can we figure out a way to impact these different clauses? And I'm going to focus more, to begin with, on this second predicate right here, and kind of focus on that separate from this top one, and take a look at what we have as far as our system. So if we look at it here, the inches of snow on the ground, wind speed, and another large school nearby closed. So if we think about it this way, I've got the inches of snow on the ground as an input, wind speed, and school closed. So if we think about it, I'm going to start my analysis here by looking at, is another large school closed? And what I want to do is I want to make this the major clause that I'm going to do for my analysis right now. So if another large school is closed, true and false, to where that governs the outcome of our predicate is going to be true if another large school nearby is closed. And it really, if you look at it, doesn't matter what these other particular parameters are. If I want my predicate to be false and another large school is closed, or is not closed, excuse me, the inches of snow on the ground has got to be less than 12, so I'm going to make that be 11. And the wind speed has got to be greater than 10, so I'm going to make that 9. So that takes care of that predicate. Now, if we focused on this a little bit more, and we wanted to take a look at making one of these other clauses be the major clause. So for example, inches of snow on the ground being greater than 12. So if the inches of snow is greater than 12, well, I need to come up with some clauses that are going to make that be the major thing that impacts the outcome. So inches of snow greater than 12. I'm going to pick 18, and I'm going to pick 11, for example. And what I want with the scenario of this 18, I want that to be true. I want that to be false. Now, if there are 18 inches of snow on the ground, and okay, for that to be the major deciding factor, the wind speed must also be greater than 10. So I'm going to put 12 here. And for that to be the deciding factor, another large school nearby being closed, that must be false. If we then take a look at this being the deciding factor, wind speed greater than 10, this needs to be 12. For that to be the deciding factor, we also want this to be false. Now notice in this particular scenario, I managed to keep these guys the same. I don't necessarily end up doing that in all particular cases. Okay, so I've done that example. Now what I want to do is I want to look at making this be my active clause in this scenario. So that's going to be my major clause. So I want true and false for my whole predicate based upon the wind speed being greater than 10. So the wind speed being greater than 10, I'm going to pick on 15 here. If that's going to be the determining factor, this guy has got to be false. And then the inches of snow on the ground, for it to be true, I'm going to pick that as being 15 inches. Now, if I want it to be false, this is going to stay false again. This is going to stay the same here. And I want that to become my deciding factor. So wind speed, I'm going to put that at being 9. And obviously you can see how that makes it now be false. Now if you think about it, based upon combinations, we have 3 parameters, or 3 clauses. So we should have 2 to the 3, or 8 combinations. But as we look at things here, there are some of these combinations that we could possibly combine together. So for example, I might be able to merge some of these and refactor some of these values potentially together to make things happen in a different way. In this example, though, I'm not sure I'm seeing that as happening quite so well. But what I have accomplished is I have accomplished now only needing 6 test cases versus 8, based on looking at this concept of active, major, and minor clauses and how they impact the outcome of the predicate. So at this point in time, you've seen the definitions for predicate and clause, short-circuit evaluation, predicate clause coverage, combinatorial coverage, active clause coverage, and you've seen these examples. These other 2 outcomes have not been covered, and that brings this video to a conclusion.